In this video, I want to start talking about triangles, how we can define them, as well as how we can categorize them. So first, how can children decide which figures are triangles and which are not? Well, they have to see if the figure has all the characteristics of a triangle. So what are the characteristics of a triangle? Well, a triangle is a closed, two-dimensional shape made of 3 line segments. So here are 4 different examples of things that would be triangles. They are all closed, two-dimensional shapes, and they're each made of 3 line segments. This shape over here, while this is a two-dimensional shape and it is made of 3 line segments, this one is not closed, so it would not be considered a triangle. Here's another one. This one is closed, two-dimensional shape, but it's not made of line segments. Instead, it has rounded sides. So these two are examples of things that are not considered triangles. There are some triangles that have special names. One of these is acute triangles. For acute triangles, all of the angles must be smaller than a right angle. As an example, here is a triangle that would be an acute triangle. We have all 3 angles that are smaller than a right angle. Next, we have right triangles. These are any triangles that actually have a right angle. That would be like this triangle here that has this right angle that we signify by a square box. Next, we have obtuse triangles. These are triangles that have an angle that is larger than a right angle. And here's an example of an obtuse triangle with an angle that is larger than 90 degrees. While these 3 are ways to classify triangles based on their angles, we can also classify triangles based on their sides. An equilateral triangle is a triangle with all sides the same length. So here's an example of an equilateral triangle where all 3 sides do have the same length. An isosceles triangle is a triangle with at least 2 sides that are the same length. Here are 2 isosceles triangles. So this is an equilateral triangle. It actually has all 3 sides the same length, but it still satisfies the condition for an isosceles triangle since at minimum 2 sides are the same length. In addition, we have this one over here that has 2 sides the same length, but not the third. Finally, we have scalene triangles. Scalene triangles have all sides of different lengths. So here's an example of a scalene triangle. We can see that all 3 sides of this are of different lengths.